Hi all, welcome back to another lecture of DBMS, and in this lecture we'll learn about indexed materialized view. So what are indexed views we'll see and why we use this indexing thing. Then we'll see the difference between standard view and indexed view. Then how we actually create the indexed view. Then we'll learn about what a refreshing materialized view, and then we'll see the difference between the refresh intervals and triggers. And then at last we'll end up the session by learning some performance benefits of indexed view. So this video is again going to be interesting and important. So stay tuned and let's begin with the very first topic of the lecture, that is indexed views. So an indexed view is also known as materialized view, stores the result of a query physically, allowing for faster query retrieval. So it is also called materialized view, and instead of the simple view where we were not storing the data in the physical storage, in the indexed view, we will be storing the data in the physical storage to and also to allow faster query. So indexed view maintains data in a pre-computed state, improving performance for complex query. So index view are beneficial for performance when querying large data sets, and they require additional storage space as well. Okay, so how we actually create an index view from the table, let's see. So we will write select view, okay, as it is like how we were creating the simple view, but here we will write one more thing, create view with schema binding. So this allows us to create basically a view in a physical storage. So with the schema binding, as now after that select trains ID, okay, count big of all, booking count, okay, from bookings train, and join trains on booking condition where train ID in both the tables should match. Okay, we have created 101, 103. 101 was twice, you can see 101 is there 2 times, so 101. So count of count big for this will be 2 times. So 1012 and 1031. Now what we are doing, go create unique cluster index. So now from this onward we are actually creating the index view. Okay, so create unique clustered index. Name it as index train booking count on what we are creating, v train booking count of train ID. So v train booking is nothing but the view table's name. Okay, so on the train ID we are doing this indexing. So on the train ID we have created indexing like 0, 1, 2, how we actually index things. So why we are doing this, so that during the fetching, like how we are matching everything and then giving out the result. So if you have saved it and managed your data in an indexing manner, so that will actually allow us to query faster. Okay, so that's why indexing is very much important, especially when the large data sets are there that will take a lot of time to fetch or to find any data rows in that millions or billions of rows. So indexing will actually help you to query fast in a minimum amount of time. It will give you the result. So that's how we actually create a view, and then put index on some columns if you want. Index can be put on one single column or multiple columns as well. So from this second query you can see create unique clustered index. So we are creating the clustered index, okay, on this view table, and from this view table on the train ID column. So this is how we create index, and we will always create in index view with using with schema binding operator. So this is the importance of indexed views, basically to allow us to faster query when the data sets are larger, and instead of dynamically store the values in a table, it actually stores in the physical location. So that's why it requires additional storage space due to materialization of data. Now the difference between a standard view and indexed view: virtual table do not store data physically and retrieves in dynamically from base tables. Okay, but in case of index, it is also called materialized view, and it actually stores the result of a query physically, improving performance for complex queries. So standard views are slower, obviously, for complex queries, since data is computed on the fly. Means after getting the query, after that time onwards, it will compute and gives you the result. But in case of indexed, it is faster because data is pre-computed and stored already. It does not need to go to the parent class and bring it on. Next is no schema binding is required. Obviously, in standards views, we don't need to use any schema binding, and indexes cannot be created on standard views. But in the index views, it requires with schema binding to lock the schema of the underlying table and must have a unique cluster. Why we are actually using this schema binding? so that it is as it is referring to the base table, right? So if there is any change in the base table, like let's suppose if some column or cell value has been updated, so as the index view is also storing in the physical, like it is also storing the data in the physical storage, but if there is any change in the base table, it should align with this view table also, so that it should be either automatically refreshed or manually refreshed, but then whatever the updated value is there in the base table, that value should be updated in this indexed view as well. That is why we use schema binding operator here. Okay, so for creating standard view, we'll just write the query like yes, select view, and then we'll give the view table name, and then we'll select all the columns which we want from table. We'll join the table on the simple condition where train ID should match. In case of index views, what we'll do, we will do the same way, but with schema binding. We will also select all the things, and we will also all the columns which we want from two tables, join it on the basis of train ID condition, and then we can also group by it. So basically, the only difference in the standard view and index view is basically in the index view we will use the with schema binding, and then for indexing some columns we'll also use the query, so that we can apply the indexing thing on the particular one or more than one columns. So let's deeply understand the query of the indexed views, which is used to create the index views, and let's see what are the basically meaning for all those terms which we have seen. So creating indexed view involves defining a view that physically stores the result of a query, right? So this is the main difference, that it actually physically stores the data. Now requiring the use of with schema binding option. So it requires with schema binding only because so that if there is any change in the base table, it will automatically get reflected or manually get reflected in the index table also. This option locks the schema of the underlying tables and preventing any structural changes that could affect the indexed view. Now how we write the query, select view. Okay, now we train booking ID is a name for the schema view table with the schema binding. So with the schema binding ensures that underlying tables cannot be modified, so dropped or altered until the view is dropped. This is important because indexed view depends on the fixed structure of underlining. So what one more benefit of with the schema binding, actually it ensures that if there is the table has been dropped or altered in the base table, then until the view is dropped, it cannot be modified. Like we cannot modify without letting the indexed view know that what the base table is going to do, like either dropping or modifying. So if you want to drop the physical table, base table, then first the index table should drop, means it should get deleted. Then if you want to modify anything there in the base table, then an indexed view table is also supposed to be modified the same way like how you are modifying to the base table. So that's what the schema binding takes care of. Now we are selecting the train ID count of big as this from bookings table, joining trains on booking ID on the condition like their train ID should be same, and then we are grouping it by trains or train ID. Now after that we are creating a unique clustered index and naming it as index train booking count. Okay, on what table? This view table, and on what column you want? Train ID. So after creating the index view, we create a unique clustered index on it. This index physically organizes data stored in the view, making it possible to retrieve the data quickly. This unique clustered index must be created on a column or a combination of columns. So that's what this is basically, creating the index, and all the index values are unique, so that if you are trying to fetch data based on the index, the exact row will come out as a result. And this indexing can be done on a column or a combination of column that ensure each row in the index view is unique. That is why that's the main purpose of creating the index, making the every row's value to be unique. Okay. Now this is how we actually create the index view, and that is what the meaning of with schema binding which we are using, and the unique cluster index why we are using and writing it. Okay. Now let's see what is refreshing materialized view. So materialized view is nothing but index view. So what is this refreshing? This means, so refreshing index view refers to process of keeping the views data synchronized with the changes made in the underlying base table. So basically, to make it synchronize, like to make it every time, to make it updated, what the indexed view table to be updated along with the parents base table. Like if there is any modifications or any changes, that should also be done in the index view. So that's what refreshing index views means. And the refresh mechanism can either be automatic or manual, and this refreshing means updating can be done automatically or can be done manually. Okay, so depending on the specific configurations. So first is automatic refresh. So it means that index view updates itself whether whenever there are any changes like insert, updates or deletes in the base table that is derived from. So automatically refresh allows the view table to automatically refresh itself if there is any changes or whenever there is any changes in the base table, either it's about inserting, deleting or updating. This feature helps maintain real-time data consistency, because it is automatically refreshing, means it is real time, it is maintaining the real time consistency. If within that if it has been, the base table has been updated now, so at the same time it will automatically refresh itself. So it is basically maintaining the consistency in the real time. But that's not happening in manual refresh. In some database, refresh operations can be deferred and executed manually. This approach is beneficial for controlling when updates occur, especially in systems with heavy load or during maintenance windows. So actually, in this case, it does not automatically refresh itself. It will wait until the manually it has been happened and it has been requested for. Benefit is that, let's suppose if there is any changes, let's suppose we are going for a Windows update, right? And that time only the base table has got changed, but it will wait so that it can complete its update. And manual, if it is manual, then we can, after the completion of the update, we can say like now we want to match basically the view table, index view table with the base table. So this is a benefit of manual refresh as well. Okay, and we actually, especially we use this type of manual refresh in case of system with the heavy load, okay, or during maintenance windows. So that is what the refreshing materialized views means. Now refresh intervals and triggers. So these are the two ways to refresh. So first is refresh intervals and triggers are the mechanism that control the timing and manner in which materialized views are updated. So these are the two techniques to update. This include setting specific times for updating or conditions under which updates should occur. So this actually help us, and this gives us the authority to basically manage the updates and give the time also, like at what time you can do that and all. Okay, so this is what each refresh pulls. So after refreshing, what happens, each refresh pulls the data from a source to data set. So in a data set, it will pull all the new update changes, and a report is generated on the materialized view. Okay, so index view in SQL Server refresh automatically with changes in the base table without needing any manual triggers. So trigger is basically, it's a manual trigger. You click, or or you have set it like after 1 hour or after 1 day, you need to trigger yourself to get the and to update any changes if there is any changes in the base table. Okay, so this is called like automatic. Triggers are defined to refresh materialized view at specific intervals or based on some events happen. So if there is any failure, then you have coded in a way that yes, this time trigger should happen, or at a particular interval that every day or every week there should a match or update in the index view from the base table. So trigger is something depends on the time or interval which you have set, and automatic is basically any change leads to automatic trigger in the indexed view. Okay, so these are two methods to basically update your index view compared to the base table. Next is performance benefits of index view. So what are the benefits for index view? So index view provides significant performance improvements for queries involving complex join and aggregation, as they store the pre-computed results, allowing our faster access to frequently queried data. So as it already stores the pre-computed values and it stores the actual data, so at every query it does not need to go to the parent class or the base class to get the data and then do the update. That will take more time. So here we have faster query execution. As well, it also allows the indexing thing that makes every row to be unique, that actually allows to fasten the query results, right? So allowing faster access to frequently querying data. While there are benefits in read operations, there is an increased overhead during data modifications. So during the read operations, it has a lot of benefits, but during the data modification, it increases the overhead, as every change to the base table must also update in the indexed views. So creating the index gives us fasten query if for the read operations, but for the write operations, obviously it has also increased, and it has, it is faster to find that particular row and then update it. But it actually increases the overhead. Why? Because every update in the base table is directly related to the update in the index table as well, either at the same time through the automatic refresh, or after some time through the manual triggers. But the updates are required at both the places, right? So for a single query, for a single row, you are updating at two places. Just think about number of rows in a heavy chunks. So that will be a overhead problem here. Okay. So if you have, like, that's an example in the IRCTC system, if the application frequently retrieves a number of bookings for each train, an index view can be created to pre-compute and store this data, leading to faster response times when user quickly query booking statistics. So that is a benefit, like in case of IRCTC, where the real time, very frequently in a milliseconds or nanoseconds, the number of data, the number of new users, the cancellation of booking IDs, allotment of seats to the users, and all those things are going on. Their fetching data is, like, in a heavy chunks data, fetching data is required. That's where we can use the indexing thing. But again, updating the higher chunks can be overhead here. So that was all about the index views, materialized view. What are the refreshing here means? Basically the updations, how we can do it, with automatic and the manual triggers, and what are the benefits, key benefits of the index views, and along with what can be the cons here. So I hope all this video was clear and you have understood each and every topic. Now let's meet in another lecture with some more interesting topic. Till then, keep learning, take care of yourself and your family too.